communication concepts, circuit designer perspective. இப்போ வந்துட்டு VLSI for wireless communication டாபிக்ல ரிலேட்டடாக பார்க்க போகிறோம். இன்ட்ரடக்ஷன் வந்து கம்யூனிகேஷன் கான்செப்ட்ஸ் சர்க்யூட் டிசைனர் பெர்ஸ்பெக்டிவ்ல வாட் டஸ் GSM ஸ்டாண்ட் ஃபார்? GSM என்ன இருக்குன்னா என்ன ஸ்டாண்ட்? What is GSM? Why is the dynamic range in the digital enhanced cordless telecommunication receiver specified to be around 93 dB? Yeah, dynamic range in digital enhanced cordless telecommunication receiver specified to around 93 dB only. What are the multipath fading and Doppler shifts? என்னென்ன மல்டிபாத் ஃபேடிங்கும் அண்டு டோப்ளர் ஷிஃப்ட்ஸ் இருக்கு. How would the noise figure requirement of a low noise amplifier change if I change my radio from one standard DVCT to another GSM? How would the noise figure requirement of low noise amplifier change if I change my radio from one standard, that is from the DECT இருந்து GSM க்கு another GSM க்கு பண்ணும்போது அந்த noise figure requirement, the low noise amplifier change வந்து எப்படி இருக்கணும்? Would Doppler shift be a problem in a standard such as PHS, and what circuit techniques do I have to address this problem? What Doppler வந்துட்டு shift பண்றாரு shift be a problem in a standard such as PHS, and what circuit techniques என்ன circuit techniques address இந்த ப்ராப்ளத்துக்கு? These are the types of questions integrated circuits IC designers may ask when dealing with the circuit design of our mobile wireless communication. இந்த எல்லா டைப் கொஸ்டின்ஸ் வந்து இங்கே இன்டகிரேட் சர்க்யூட்டில் டிசைனர் வந்து எது கேட்கலாம்? டீலிங் வித் சர்க்யூட் டிசைனும் அல்ஃபா எதுக்குன்னா mobile wireless communication. Unfortunately, IC designer must be familiar with the diverse source knowledge, and each of these sources is written for a specific circle of engineers. So finding and integrating relevant knowledge across these disciplines proves difficult. Unfortunately, IC designers வந்து must be familiar with the device source knowledge, and each of these sources is written for specific circle of engineers. So finding and integrating relevant knowledge வந்து across these discipline proves difficult. Prove பண்றது difficult. For example, if you need to understand modulation techniques such as quadrature phase shift keying QPSK, and you consult a standard communication text, you would find that the design trade-off is typically presented using channel capacity and the demodulators signal to noise ratio SNR as key parameters. For example, if you need understand modulation techniques such as quadratic phase shift keying QPSK, and you consult a standard communication text. ஓகேங்களா? You would find that design trade-off is typically presented using channel capacity and demodulator signal to noise ratio is a key parameter சொல்றாங்க. This is of little use to a circuit designer who is more interested in SNR of the whole receiver than that of demodulator itself. அதாவது சர்க்கியூட் டிசைனர் வந்து who மோர் இன்ட்ரெஸ்ட் இருக்காங்க, நீ எஸ்என்ஆர் அந்த ஹோல் ரிசீவர்லேயும் எஸ்என்ஆர் பார்ட் மட்டும் யார் இன்ட்ரெஸ்ட் இருக்காங்களோ then that of demodulator itself அவங்க வந்து இது யூஸாக இருக்கும். nor is channel capacity a relevant parameter since circuit designers have no control over it. otherwise இல்லைன்னா channel capacity வந்து relevant parameter மட்டும். Since circuit designer have no circuit designer வந்து என்னது no control over it. On the other hand, if you go to the classical radio frequency, that is RF radio frequency circuit text, you will be exposed to figures of merit such as input, third order intercept points, IIB3 of individual circuit subcomponents. வேறு வகையில் other hand, if you go to classical radio frequency RF போனீங்கன்னா circuit textல you will be exposed to figures of merit such as input, third order intercept points, IIP3 of individual circuit subcomponents. However, in the column you will not find any interpretation as how they affect overall receiver performance such as the bit error rate per. However, you will not find any interception as how they affect overall receiver performance such as the bit error rate PR. Thus, this information may not be very useful to a modern day integrated circuit designers who has the whole receiver to worry about and therefore would also need to interpret and relate figures of merit of individual circuit subblocks given in circuit terminology to the performance measure of the whole receiver given in communication technology. அதாவது that the information may not be very useful இருக்காது to a modern integrated circuit designer who has whole receiver to யார் வந்து whole receiver worry பண்றாங்களோ about and therefore would also need a interpret and relate figures இருக்கு merit of individual circuit subblocks given in the circuit terminology to the performance measure of whole receiver given in a communication terminology. இது வந்து receiver வந்து communication receiverலையும் performance measure of performance whole receiver உடைய performance measure பண்றது given in வந்து communication terminology figures of merit of individual circuit subblocks வந்து given in circuit terminology இருக்குது படிக்கப்படும். Often this performance measure is the only information available to an integrated circuit designer. அதாவது அப்போ this performance measure இந்த performance எது measure பண்ணல only information available to இது integrated circuit designer இருக்கு, அப்போதான் அது வந்து available ஆகும். Hence the following questions likely what would be a poor receiver IIB3 do the first pair for P, that is PR bit error rate, a standard using Gaussian minimum shift gain.
The performance measure is the only information available to an integrated circuit designer. Hence, the following are likely. What would a poor receiver IAB3 to the PER for the standard using Gaussian minimum shift gain? Poor receiver IAB3 to the PER for a standard using Gaussian minimum shift gain. If modifying the modulation to reduce the required IIP3 of receiver a reasonable option. If modifying the modulation scheme to reduce the required IIP3 there is a responsible option. Yet a classical RF circuit test is unlikely to answer these questions. Classical RF circuit unlikely to answer these questions. Therefore, it is the goal of the under the text chapter to address these questions. However, to present the answer in a language that most integrated circuit designers can be understand. However, overview of wireless systems. In this section, we review a basic communication system. So, as shown in figure 1.1, such a communication system consists of a transmitter, channel, air for wireless communication, cable for wireless communication, and receivers. So, in subsequent, we review the basic communication system and the figure 1.1. That the communication system consists of the transistor, channel, that is air for wireless communication, cable for wireless uh, communication, air for wireless communication, cable for wireless communication, and the receiver. In typical communication system, the modulator in the transmitter takes the physical signal from the source of modulates it on a high frequency carrier. அதாவது in typical digital communication system, the modulator in the transmitter the modulator takes a physical signal from the source and the modulator it on a high frequency carrier. The back end conditions the modulated signal to form the suitable for transmission. அதாவது the back end the condition is the modulated signal to form suitable for transmission. The channel takes these transmitted signal and adds distortion, noise, noise, interference, and other environment to it. So the receiver consists of a receiver and front end that takes is highly impaired signal and the condition is form that the demodulable. Next, let us review specifically what wireless communication channel is here in the okay is about mobile wireless communication system where the users with the opportunity to travel freely within the service area. அதாவது mobile wireless system provide users with the opportunity to travel freely within the service area. These systems are made possible. The system is possible Why the unique property